Rosalind Elsie Franklin was born July 5, 1920 in Notting Hill, London, to a well-known Jewish family. Rosalind was the second child and eldest daughter of 5 children. Her father, Ellis Franklin, was a banker who taught electricity, magnetism, and the history of the Great War at the Working Man's College. Rosalind attended St. Paul's Girls' School from 1931 to 1938, where she excelled in science, Latin, and sports. Rosalind left St. Paul's in 1938 to enter Newnham College, one of the 2 women's colleges at Cambridge University. Franklin majored in physical chemistry and received her Bachelor's of Arts in 1941. She was awarded a scholarship for another year of research and a research grant from the Department of Scientific and Industrial Research. She started work at the British Coal Utilization Research Association, where she studied carbon and graphite structures of coal. This became the basis of her doctoral thesis. She received her PhD from Cambridge in 1945. After obtaining her PhD, Franklin found a research position in Paris, France. She learned how to analyze carbons using X-ray crystallography and became very skilled in the technique. X-ray crystallography, also known as X-ray diffraction, is a method used to determine the atomic structure of a crystal. An X-ray beam is directed at the crystal, the X-rays bounce off the atoms that make up the crystal and form complex but regular patterns. Detailed analysis of these patterns enables the precise determination of the crystal structure. In 1950, Rosalind was awarded a 3-year Turner and Newell Fellowship to work in John T. Randall's Biophysics Unit at King's College London. Rosalind, with the help of graduate student Raymond Gosling, was to use her skills at X-ray crystallography to investigate the structure of DNA. DNA is a molecule that contains the genetic code for the entirety of living organisms. The structure of DNA was something of a mystery until Rosalind Franklin's famous Photo 51. We now know, thanks to Franklin's work, that DNA is found as a double helix with a phosphate and ribose backbone. At the same time, at the Cavendish Laboratory at Cambridge, Francis Crick and James Watson were working on a theoretical model of DNA. In January of 1953, they were shown a summary of Rosalind's unpublished work submitted to the Medical Research Council. Photo 51 gave Watson and Crick the last bit of information they needed to elucidate the DNA structure. Watson and Crick published their paper on the structure of DNA in the journal Nature in April of 1953. They gave no credit to the photo they saw from Franklin's work. Rosalind Franklin also published her findings in the same journal, but was third, making it look like her findings supported the article written by Watson and Crick. By the time the articles were published, Franklin had transferred to a position at Birkbeck College, where she studied the structure of tobacco mosaic virus. Franklin took meticulous X-ray diffraction photos of the viruses, and her expertise in these structures was recognized by the Royal Institution in 1956, when its director honored her with a request to construct large-scale models of rod-shaped and spherical viruses for the 1958 Brussels World's Fair Science Exhibition. In the fall of 1956, Franklin was diagnosed with ovarian cancer. For 18 months, she underwent surgeries and treatments while continuing to work in her lab and seek funding for her research team. She died in London on April 16, 1958. Francis Crick, James Watson, and Rosalind's lab mate Maurice Wilkins won the Nobel Prize for Physiology in 1962 for their work on nucleic acids stemming from the discovery of the structure of DNA. Not a single one gave credit to Franklin at the time. Franklin died in 1958, making her ineligible for the Nobel Prize, so we will never know if she would have received the credit she was due. Throughout her 16-year career, Franklin published steadily: 19 articles on coals and carbons, 5 on DNA, and 21 on viruses. In the past few decades, Rosalind Franklin's contribution to science has started to be acknowledged. Franklin was made an honorary member of a variety of societies, had buildings named after her at King's College and Newnham, and in 2004, a college in Illinois was renamed the Rosalind Franklin University of Medicine and Science. Franklin's contributions to the field of science are great and immeasurable. Despite never receiving proper credit for her work on the structure of DNA, it is clear that she played a pivotal role. Watson and Crick wouldn't have created the structure they did without her.